Hey, this is Mrs. J, and today we're going to look at Project Lead the Way POE force vectors from Unit 2. You're going to hear my puppies in the background. I apologize in advance. All right, let's take a look. So with force vectors, we're just looking at some forces on an object. This video has sound. Ignore that. Has sound. Okay, we're going to look at vectors. You might know this from your typical math class. You'll see it in trigonometry, you'll see it in algebra. Depends on the course you're taking. We're going to look at vector quantities. And really what we're talking about is something that has a force, and we're looking at magnitude and direction. Magnitude is how much. Direction is which way. How much is happening, which way is it going? To write it down, we typically write it with a letter indicating what's happening. It's not necessarily an A or B, it's whatever it is. But it has a line going across the top of it that's an arrow. Whenever you see the arrow, you know we're looking at a vector. Vector means it's a line that's got two things going on. It's got magnitude, how much, and direction, which way is it going. Important when you're doing engineering and you're putting tension on items. So vectors, we use arrows, and we have three things going on: magnitude, direction, and sense. You don't see sense too often other than in the educational workspace. You'll probably see it in college, but you won't really see it in your regular work day. So magnitude is, in this case, the length of the line segment. So if you look at this and you break it down, it would be in three sections: 1, 2, and 3. Can you see that? Yeah, that's how much, right? Magnitude, how much. Direction, which way is it going? Well, we have a positive x-axis down here, typical x-axis going to the right. It looks like there's a space in between it. It's got 30 degrees. So this arrow is going upwards. It's also going to the right. So we would say, and we'd indicate with the arrow, that this vector is going 30 degrees counterclockwise, because it could spin, right? If it had a moment, it could spin counterclockwise from the positive x-axis. A sense tells us that the tip of the arrow, and this isn't used too much. I saw it in college for like a hot minute, but it's just saying that it's going upward and to the right, as opposed to up and to the left, or down to the left, down to the right. So we know because it's going counterclockwise and it's coming off the positive axis, it's going up it's going up and to the right. That's the sense. So to get a better look at sense, and we'll probably only look at this one time, but you might see it on your EOC, and I like the graphics on this, helps me understand. A regular, typical, you see the origin here, X and Y axis, right? X going this way, Y going this way. So X horizontal, Y vertical, just like you would see in your math class. If you're looking at this top right corner, you would say that the positive x-axis goes to the right. Positive y-axis goes up. So this vector, this red arrow, would be up and to the right. Again, if we brought it down here and this arrow was coming down here, we'd say, well, y is going down, so it's going to be negative because it's below our x-axis here. But the x is still going to the right, so we're going to say that's positive. So we would say that this arrow is going down and to the right. If we brought it over here on this quadrant, we would say that the y is now down, just like over here, because it's below our x-axis. And then our x is also negative because it's going to the left, because it's crossed that y, that vertical axis right there. So this one is going down and to the left. And you can guess the last one. It's up and to the left. So you're looking at the red arrow. Up to the left, positive because it's up, but it's negative because it's left of that axis. So just something to wrap your brain around and see if you can get understood, not so much memorized. Okay, going back to your old days of trigonometry, you probably already know this stuff, nothing new, so we'll whiz right through it. If it's new, you can take a look at this a little slower, and I have some more help for you on a separate one-stop shop tutorials. Okay, right triangle. So if you have a right triangle, you know you have a 90-degree corner in there, that angle right in there, right? If you added up all the angles, they have to be 180. 180 we know is a straight line. So if I open this, open that, I'd have a straight line. And then your Pythagorean theorem is always a squared plus b squared equals c squared. For some reason in college, they like to write it this way. When we have this, we have the hypotenuse, which is generally where we see our vector. We'll see a vector, and it'll have a magnitude and a direction. And then we've got to figure out the opposite side and the adjacent side. So in order to do that, we use a little something called SOHCAHTOA. I know it's your favorite. Let's run through it just in case you haven't seen it in a while. Some of you are doing it right now in your math classes. I know that. But we're just going to take a little run through. If it's new to you, it's actually kind of fun. So SOHCAHTOA is just a way of using some small letters and mnemonics, I think they're called, to remember. We like to look at the sine, the cosine, and the tangent of the trigonometric functions. And in order to remember that, we say SOHCAHTOA. For so, those are my dogs you hear, sorry. We're going to say that the sine of the angle theta is equal to the opposite divided by the hypotenuse. So to use this, you look up here. Sine is equal to the opposite divided by the hypotenuse. On the picture, you would say the sine of this, sine of angle theta, is equal to the opposite divided by the hypotenuse. Hypotenuse is always that longest side there. Even though this says S-I-N, we say it sine. That is always a thing. Don't say sin. I hear that a lot. It's incorrect. For cosine, so the actual spelling is S-I-N-E. But this is how we write it because that's how it is on your calculator. Did you know that? Cosine is C-O-S-I-N-E. We don't say cos, we say cosine. So for this one, C-A-H, we say that the cosine is equal to the adjacent divided by the hypotenuse. Or cosine of angle theta is equal to the adjacent divided by the hypotenuse. If you look on the graph, on the picture, the graphic, it's the same angle they're talking about. So this angle theta, meaning they didn't give it a number. They could have said 35 degrees, but they didn't. So we'd say the cosine of this angle would be equal to the adjacent right next to it, divided by the hypotenuse. We use different ones based on which values we have and which values we're looking for. Tangent we don't use too often. It's kind of fun. It's a little tricky. So tangent, T-A-N-G-E-N-T. We don't say tan. We always say tangent. It's equal to the opposite divided by adjacent. So SOHCAHTOA. See how they did that? It's always sine, cosine, tangent. And it's always this divided by that, this divided by that, this divided by that. So tangent of angle theta is equal to the opposite divided by adjacent, or they're talking about the same angle. I'm mentioning this multiple times because that's what I see come up on quizzes where students are confused. Tangent of angle theta is equal to the opposite side, all the way over here, divided by the adjacent side. Pretty easy, right? Okay, so let's look at it in a visual form. This is not something you have to memorize or will be tested on, but I like this. My brain understands this so much better than seeing SOHCAHTOA. That's just a bunch of letters to me. This makes sense. So if you look at the sine right here, and we're on the x-axis, right? So each one of these is going to look at the x-axis and what's happening with sine, cosine, tangent. For sine, you start at the origin, right? Make a beautiful curve. You hit a straight line 180 degrees, right? And then you curve it back up 360. It continues on forever. Just beautiful. For the cosine, we come up on a value of 1. So it's the same thing, but see right here? See this 1? It come up to the 1 space here. Cosine starts there. Can you see that? This red could be that and continue on. This red comes down at 90, comes back up at the next 90, 270, right? See how it goes there? 90, 180, 270, and then it comes back up and just continues on and on forever. So they cross over. This cosine could come up here and it could come down through 90, under 80, up to 70, and they never crisscross, and it's just so pretty. Oops, I'm sorry, didn't mean to roll that. Tangent also starts at the origin, just like sine, right? But it comes up to 1, and it comes up right at 90. See that? It's also down here, below 90, up at 180, and then it comes up at 270. Repeats itself. Just beautiful. Enjoy that. Okay, we're going to look at a couple more slides, and we'll call it a day. 4 more slides, and this will be the end of part 1. Let's try a practice. So we have a very simple vector here. We're going to call it F. Same thing as before, A or B, but we're going to call it F. Because now We're in engineering, we want to say that, well, there's a force on here. How can we help it? We're hanging something, a picture, a speaker. We like to hang our TVs on walls, right? So something could be holding it there. So let's say the hypotenuse is the vector F. We have the angle. We have an adjacent side, which is along the x-axis. Can't talk. It's along the x-axis, so we're going to call it f of x. And then we have the opposite side, which is along the y-axis, right? So we're going to call it f of y. Let's see if I can get this to go forward. I broke it. There you go. All right, the hypotenuse is the magnitude of the force F, or how much. In the figure here, the adjacent side is f of x, and the opposite is f of y. We just said that. They don't have to tell us twice. So we can look, oops, puppy. So we're just going to look at sine. Remember, it's SOH, S-O-H. So the sine of angle theta would be equal to the opposite, which is f of y, divided by the hypotenuse, which is f. Can you see that? Sine f of y divided by f. F of y divided by f. If I get this to go. If we were to look at the cosine of this angle theta, we would say that it's CAH, C-A-H, or the adjacent f of x divided by the hypotenuse f. So we would say C-A-H, f of x divided by f. So practice that so you understand it. Tangent, TOA, T-O-A, the tangent of angle theta is equal to the opposite side divided by the adjacent side. We don't see that too often. It's pretty cool that it happens. We can move it around. We can say, hey, we want to find f of y, or the opposite side. So we just take exactly what this is. Can you see what they did here? They said that if you took this, because it's f of y divided by f, if you moved it to the other side, f times the sine of theta would be f of y. Same thing here. F times cosine of theta would be equal to f of x. See that? They wrote it differently, but f of x is equal to f cosine theta. So put that down on your paper and put this under it. I think it helps with your brain a little bit more. F of x divided by f. And then you just move it to the other side. Okay, last thing we're going to look at, and we've got two slides here, the vector A. So see how they wrote it with the arrow on top of it? They gave us a magnitude, or how much. 75 pounds. Whenever you see a weight, you've got a magnitude, because how much is happening, right? What's the direction? Well, it's coming off the x-axis down here, and it's going this way. The moment, that's what we call it, is turning. If nothing stopped it, it would go counterclockwise forever, indefinitely. So it's going 35 degrees counterclockwise. I know that because it's going up this way from the positive x-axis. Its sense is to the right and up compared to the xy axis, right? Pretty good, right? So we have the opposite, if you drew a line here, would be the force of vector A in the y direction, and adjacent would be the force of vector A, I said angle, I meant vector A in the x direction. So it's your job to take this vector and fill it in to make that right triangle. That's why they brought up that simplistic right triangle in the beginning of this lesson. So did you see that? Let's go back one more time. You have a vector. You have the angle between the vector and the x-axis, right? You want to fill in the x-axis right to the edge where you see your vector stopping. And then you want to bring it up. So close up your triangle. Then you've got your hypotenuse, your adjacent, and your opposite. It's always from the theta. That's how you plan it. You can do all of your math here, and you always have to solve for two things. You have to solve for FAX, which is the adjacent side of your triangle, and then FAY, which is the opposite side of your triangle. So in order to find FAX, we're looking for this down here. We only have two things. We have the magnitude, 75, we have the theta. The only thing that really works here is cosine. So let's consider why the others don't work. If you were to look at sine, sine wants the opposite over the hypotenuse. It doesn't ever ask for the adjacent. And this question says solve for FAX, which we know is adjacent. So sine's out quickly. Cosine works because it has the adjacent divided by the hypotenuse. So you could solve and find what the adjacent side is, FAX. But if you were to look at tangent, or TOA, right, TOA, you would say the tangent of this angle would be equal to the opposite divided by the adjacent. But do you have a value for the opposite side? Not yet. So you would only have one value if you would use TOA. You'd only have the tangent of 35. You don't have the other two, so it doesn't work. So this is the only one that could work for this. Cosine is equal to the adjacent divided by the hypotenuse, or CAH, right? Fill it in. What is adjacent? FAX right here. And then what is, where am I? Hypotenuse. Hypotenuse is your vector A. So you just have to fill those in. We know we have 75 pounds for the vector. We know we have 35 degrees for this theta, this angle theta. So we can fill those in. Cosine of 35 degrees is equal to FAX, or adjacent, divided by 75 pounds. You'd have to move this 75 pounds over from being divided to the other side to be multiplied so that you can get FAX, or the adjacent side, isolated by itself, so you're solving. So let's put that all by itself. And we could say that FAX, we brought it from here, is equal to 75 multiplied by the cosine of 35. You could ignore the up for now. Now, when you're in your calculator, you need to test it out once or twice and get some correct answers. It's easy to say yes to this slideshow, but calculators are different. I have two in front of me. One of them has a parenthesis that opens up the minute I hit the cosine function, and I have to close it for the answer to be correct. If I don't close it, I get a syntax error. I have another one that doesn't come up with parentheses, and I have to continue like that. If I add parentheses, it doesn't work. So practice it right now. Do 75 times cosine 35, close your parentheses, and hit the answer button. It should be 61.4 or something like that. We might have rounded here. Okay, and then the next one they asked you for is the y component. We just did the x component. Now we're going to look at the y component. That's right here. So you're good there, right? So for the y component, we're pretending we don't have FAX right now. We didn't get it yet. We know we have two things, 75 pounds, 35 degrees. The one that works the best is sine, or SOH, S-O-H. You could say the sine of angle theta is equal to the opposite divided by the hypotenuse. See that there? So the opposite is the force of vector A in the y direction, or in the y-axis, along the y-axis there. This is the one they told us to solve for, so we really want it to be in our equation. The only other one that has the opposite in the equation is tangent, and tangent has opposite over adjacent, but right here you have opposite and adjacent. You don't have the value. I know you just solved for it, but we always solve as if we didn't, right? Okay, so we're going to use sine. I'm going to say that opposite is FAY, and then hypotenuse is the vector A. So we have this value, 75. We have theta, 35. We don't have the opposite. We don't have FAY. So we're going to get FAY by itself by taking this 75 pounds and moving it to the other side of the equal sign. It was divided. Now it's multiplication. So we can say that the force of vector A in the y direction, or the y-axis, I have to get my terminology proper, I apologize, is equal to 75 pounds multiplied by the sine, say it correctly, sine, of 35 degrees. You can ignore the up-down for now. That's not something I'll test you on. It gets confusing. If you put this in your calculator correctly, 75 times sine, hit the sine button on your calculator, 35, close parentheses, puppies, maybe they'll be quiet, you should get 43 or something very close. And I think, hold on, sorry about the puppies. So the next one you can try on your own. It's vector B. It's very similar. The only difference is it's down and to the right. So you get a little bit of a change here. I'll run you through it quickly, but I think you can do this on your own. Figure out the magnitude. That's how much it weighs. Figure out the direction, 35. Now we're clockwise, right? Because we left the x-axis and we came down, right? We left the positive x-axis and we came down. The sense is right and down. So we have to be careful with the negatives here. And this is vector B. They ask you to solve for FBX, and then they're going to ask you to solve for FBY. It's always the same thing. You're solving for your triangle. So you have to create your triangle. What's that populate in the beginning there? You'll see this on a test. You have to create that triangle. That's all you. Okay, so for this one, we have to figure out if we're solving for FBX, it's adjacent, right? Because you see your theta, what's right next to it? Well, I've got my magnitude or my vector, right? It's my magnitude. But then I don't have it here, so this is adjacent, FBX. Opposite, FBY. You might have to label this yourself. Cosine works best because we have adjacent. Well, we're looking for adjacent. We have magnitude and we have theta. So you just fill it in. SOHCAHTOA, C-A-H, cosine of 35 is equal to FBX divided by 75 pounds. Come all the way over here. Cosine 35 is equal to FBX divided by 75 pounds. You got to get this by itself. This is the same as this, the adjacent side. We're going to isolate it by taking this divided 75 and bringing it right here. These are three separate things. We're just populating the formula. This is your formula. This is you filling in the names for your formula. This is you putting in the values that you have available to you. So if you say 75 times the cosine of theta, you could put that right here, and it's equal to FBX. When they say it's going to the right, they're talking specifically about this line. This line right here is going to the right. It's not going up, down, or left. It's just going to the right. And that's what they mean for each one. It's a little confusing when you do it, so I don't push it. But that's all you need. Calculator, 75 times COS feature, cosine, press it, and then close your parentheses after you enter 35. Close. You should see 61.4. Pretty good? Okay, let's try the next one. This one says solve for FBY. We know it's going down, right? So automatically we can say, all right, what's its sense? Its sense by itself is down. They're talking about this, FBY, this one side. So for this one, we can choose to use sine. This is the hardest thing to figure out what to use. We have SOHCAHTOA. We really don't like to use tangent unless we have to, because it has a little bit more going on. You saw its picture, right? So we can use sine or cosine for this one. We can look at it. We just use cosine, right? But let's look at sine here. We could say sine has the opposite over hypotenuse. Well, opposite is what we're looking for. So we want to pick one out of SOHCAHTOA that has opposite in it. It's only sine or tangent. We don't want to use tangent, so let's try sine, and that works. So we could say sine is equal to FBY divided by the hypotenuse, which is 75. I know it's the hypotenuse because it's the vector, it's the arrow, and it's the longest side of this triangle. So I can say the sine of 35 degrees, that's our angle theta, is equal to FBY, or the opposite side, divided by the vector B. I know the vector B is 75 pounds. Why do you think they put a negative sign here? Let's go back to FBY. Is it going up, positive, or down, negative? Remember, negative is in this direction. That's why they added that there. So we can ignore that for a minute and say that 75 divided here. It's divided, right? We can bring it to the other side. Same thing as before. 75 times the sine of 35 degrees is equal to the opposite angle. We're going to put a negative sign. You won't see this in your calculator, but because the angle is going down under the x-axis in the negative y direction, you add the negative sign. Tough stuff here, right? But you could do this. I know you do it in your math classes. Okay, that's pretty much all we have for now. In the next video, we will look at some practice problems. Thanks for watching. Have a great day.